Tristan again, and welcome to another video. In this video we're going to be doing 1.2, impact forces. And first things first, we're going to need to remember our formula. Force is equal to change in momentum over time. And if we think of an impact force as being a ball hitting a plank, the ball exerts a force on the plank, and the plank exerts a force on the ball. This is Newton's third law, which states that every action has an equal but opposite reaction. Now in this case, the momentum of this ball will be mu, and the momentum of this ball rebounding will be v. Now, to find the total momentum, we basically need to add these together. But to make this simple, we think of to the right as being positive and to the left being negative. So to find change in momentum, we had mu minus mv. But in this case, that would equal 0. And momentum would not be conserved. So this is not correct. So what we do is show that mv is minus. So what we end up with is mu minus mv, which will be equal to the two combined. Now to write this simply, we can just say 2m u plus v. This will give us our final or total momentum. Now, if velocity remains constant, we will have mu minus mu, which can be simplified to 2mu. Nice and easy. So in this case, our velocity is constant, which means it's an elastic collision, which we'll go on to later. And in this one, the velocity is not constant, so we must find both of them. Now, another example, which I'll do on another sheet of paper, could be that the ball hits the bat at an angle and bounces off. Now, if we imagine the ball is following this line, we have an angle theta here, which we will assume is the same. Now to find the momentum of this ball, it's going to be its mass multiplied by velocity, except we're going to need to find the component of its velocity along this horizontal plane. Now to find that, we can draw a triangle, and if we know that to be v, and we know the angle is here, opposite, adjacent, we know that to find horizontal, we're going to need to do v cos theta. Now this is the horizontal component of velocity in this case. Now to find the momentum of half, it's going to be m multiplied by our v cos theta. This will be our momentum. Now we can apply a similar rule that we used before. If the velocity remains constant both times, after and before the collision, we can assume that this will be the same. So it will become 2m v cos theta. Nice and simple. So it's the same rule, we're just finding a component of velocity rather than its velocity. Now, let's move on to some questions. and see how they go. So, summary question 1. What we have here is a 2,000 kilogram lorry reversing at a speed of 0.8 meters per second. And the fence will stop the lorry in half a second. Now, question 1, or part 1a, asks us to find the initial momentum of the lorry. The initial momentum of the lorry will quite simply be P equals mv. We have mass, we have velocity, so we can do 2,000 multiplied by 0.8, which gives us 1,600 kilogram meters per second. That is part A. Part B asks us to find the force. Now, if we remember that force is equal to change in momentum divided by time. We have time. We know that the lorry stops, so we know that v will be 0 at one point, and then we know that v is 0.8. So we can go mass, which will remain constant, multiplied by 0 minus 0.8. So that's the top, that's change in momentum. And we divide this by 0.5. This will give us 16,000, same answer there, divided by half second, which equals 3,200 newtons. Nice and simple. Let's move on to the next one. Question 2. We're told that a car of mass 600 kilograms is travelling at a speed of 3 meters per second, and it is struck by another car. The impact lasts 0.4 seconds, and the speed increases to 8 meters per second. So we know that before the crash, crude car, it weighs 600 kilograms, is travelling at 3 meters per second, and we know that after the collision, it still weighs 600 kilograms, but it's moving at 8 meters per second. And it took a time of 0.4 seconds for this to happen. With this information, they ask the change of momentum of the car due to the impact. Now we know that the initial momentum will be m times v, which is 3, or 600, multiplied by 3, which gives us 1,800. So this is our initial momentum. After the collision, we have the same weight of mass multiplied by 8 meters per second. Now this is 4,800 kilogram meters per second. So the change in momentum will be the final minus 1,800, which means the change in momentum is 3,000 meters per second. There we go. Now, to find the impact force in part B, we use F is equal to change in momentum over time. Going to get lots of practice in this. We know that the change in momentum from the previous part is 3,000, and the time taken is given in the question, 0.4. So, we know that 3,000 divided by 0.4 is equal to 7,500 newtons. So we find that the impact force is 7,500 newtons. Right. Question 3. molecule of mass 5 times 10 to the power of minus 26, moving at a speed of 420 meters per second, hits the surface at right angles. When you hear this, you want to remember this diagram. It's hitting there, coming back, 90 degrees, right angles, to the surface, and rebounds at the same speed in the opposite direction. So that way. And the velocity is constant in the question. The impact lasts 0.22 nanoseconds, which is the equivalent of 0.22 times 10 to the minus 9 seconds. Got to be careful with these units. Now, it asks us to calculate the change in momentum. So, the change in momentum, as we saw earlier, will be initial, mv, and mv will be the same on the way back, so minus mv, because it's going left. So we have mv and minus mv. So what we can change this to is that the change in momentum will be equal to mv minus mv, except this is negative itself. So the minuses cancel, and we get change of momentum equal to 2mv. Now, if we substitute the numbers we're given, 2 multiplied by 5 times 10 to the minus 26, multiplied by 420 meters per second, we will get an answer of 4.2 times 10 to the minus 23 kilogram meters per second. Now, because it's moving to the left, the answer can be written as negative this number to show it's going left. Now, part B. What is the force on the molecule? Well, again, we need to find force, so we need change in momentum, and we need time. We just worked out change in momentum, 4.2 times 10 to the minus 23, don't worry about the minus sign, divided by time, which we're given as 0.22 nanoseconds, which would be times 10 to the minus 9. And this will give us an answer, a lovely answer, let's hope. Gives us an answer of 1.9 times 10 to the minus 13 newtons. So this is the force the molecule exerts on the surface. Now, again, if we were keeping the minus sign, this would be a negative number. So it's this force being exerted by the surface to the particle, causing it to move to the left. So just think of the sign as letting the examiner know its direction. Now, last question. Question 4. It says, use the calculation, or repeat the calculation in question 3 for a molecule of the same mass, so 5 times 10 to the minus 26, again. It hits the surface at an angle this time. So there's the normal. This is 60 degrees. Now, particle hits there, rebounds. It's going to keep the same speed again, so 420 meters per second. And is the collision time the same? Yep. And the collision time is the same. So 0.22 nanoseconds. Right. Now what we're going to do is find the component, the horizontal component. So we're going to be using cosine. We're going to go 420 meters per second cos 60, because that's the angle we get. Now this, if you remember the triangle, we have 420 there, we have theta there, so we use cos to find x. X is what we want. So this gives us 210 meters per second. That's one. So its horizontal velocity is 210 meters per second. Now, if we want to find the momentum, as we do in part A, we're going to need to do 2 multiplied by its mass multiplied by its component of velocity, which we've discovered to be 210. This will give us an answer. Gives us 2.1 multiplied by 10 to the power of 23. This is our momentum, or change in momentum. So that's part A. And again, because it's moving away from the surface, we want to add a minus sign. Now part B for this, again, we use the change in momentum we calculated, minus 23, and divide that by our time, which again, 0.22 times 10 is a minus 9. And this will give us minus 9.54 times 10 to the minus 14 newtons. So this is our force. I hope that's been helpful. Please like, subscribe, and I'll see you in the next video.